So, welcome to lecture 2 of Battlecode. Oh, the projector's not working. I have no idea why. Yeah. Cool. It's working now. Okay, so this is lecture 2 of Battlecode 2025. We're going to be talking about three things. First, how to set up the IDE with the Battlecode scaffold. Second, introduction to Java and a little bit of Python 2. And third, an introduction to Git. So let's start with setting up the Battlecode 2025 scaffold. So navigate to this page right here, play.battlecode.org/ or I think you can just go to play.battlecode.org and click on the quick start tab over here. And then scroll down to installation setup. First, you on Java. I'm not going to walk through all the steps of this, but basically you just go to this link. Here we go. And then you can see there different download links. You might have created an Oracle account. If you need help with this, then you can ask us after this lecture. Second, I'm going to okay, sorry about that. I was messing with some doing things. Okay, let's continue. So after you install Java, you want to install Java 21 by the way. You're going to want to download the scaffold. So go to the scaffold link right here. Sorry, where's it? Okay, I'm back. Sorry about that. So, okay, now I'm finally going to download scaffold. So go to this link right here. So the GitHub page, you're going to want to either clone or download, which I think is called something else. It's right here. Download zip. So click on code download zip if you want to just download the scaffold by itself, or if you want to use Git, then you can go to use this template, create a new repository. You're going to need a GitHub account for this, I'm pretty sure. So this is selected, the 25 scaffold. Type in the repository name, you can just do whatever. It says private, if you don't want other teams to see your code. Create a repository. Okay. After doing that, you have your own copy of the Battlecode scaffold, and you can make changes to this copy without affecting the version. So you're going to want to clone this locally. So there are a few ways you can do that, but one way is to use the terminal. So let's go to git bash. Actually, let's use VS Code for this. Yeah, so you can just search up how to do it in the terminal. Just git clone, and then there's extra syntax. But VS Code is a lot quicker if if you have Visual Studio Code downloaded, then you can go into, I'm not sure exactly which extension you need for this, but it's one of the Git ones. I think it's probably this one. It's probably Git ones. Then you can go into the command list, go to git clone, search, it'll come up, go from GitHub, type in the repository name, which is just going to be your GitHub username, slash Battlecode 25 bot2 if you called it that, or whatever you called it. Open it up, select a folder, and then Visual Studio Code will do all the cloning for you. Let's open this. Okay, cool. So now we have a local copy of this repository. Next step is going to be download an IDE. So there are two options. You can also use probably basically any IDE. Visual Studio Code works, but these are like the easiest to set up, and there's instructions right here. So I'm going to demonstrate Eclipse. So first, go to this link. And then there's a link right here. You can download this. This downloads the Eclipse installer. This is Windows, so it might look different on other operating systems. But once you download this, you just go through the steps and select Eclipse IDE for Java developers. That's important. After you've installed it, then open Eclipse. I've already installed it, so I'm not going to go through that again. Let's wait for this to open. The projector turned off. Oh, it's back. Let's just wait for Eclipse to open. Sometimes it takes a while. Here we go. So if you're opening Eclipse for the first time, navigate to a folder where you want to keep your workspace. This should probably just be an empty folder that you create just for this purpose. And then select Browse, select the folder, and then launch. Then Eclipse is going to take a little more time. Then we'll open up with the workspace. Okay, so here you go. This contains my original attempt of doing this, so I'm going to ignore that. And once you're in here, to get to to import the scaffold, you go to File, Import, Gradle, open this existing Gradle project, click Next, and then select the directory that you cloned the GitHub repo to. So that's this one. Then click Finish. and we just wait for it to import the project. Oh, by the way, this is all for Java. The Python process is on this tab. You've probably seen it already. But it's relatively simple. I'm not going to go through it today because most competitors are in Java. Okay. So there's an error here. Pretty sure this is the same thing that happened when I tried it before, so I'm going to try to do what I did to fix it. What I had to do before was go into the folder, get rid of all the non-Java stuff. Or actually, I'm just going to copy everything in the Java folder into the project folder. And then after that, reopen Eclipse. I don't know what this is doing. Okay. And we'll wait again. Eclipse, for some reason, takes a really long time to load. Oh, that's faster. Okay. So launch Eclipse with the same workspace. And it should open up to the same project, if I'm not mistaken. Yep. Okay. So it's Battlecode 25 bot 2 I'm doing in this example. So now it should have worked correctly with no errors. Maybe it's still, yeah, it's still doing it. So let's see what happens. Okay. Yep, it worked. And now in Gradle tasks, you can expand this thing here. And if you don't see anything, you can refresh the tasks like that. This tiny button right here in the top right corner of Gradle tasks. If you don't see the window, you can also go into window. I think it's probably in show view or something right here. Let me see. Yeah, if you don't see it, go to window, show view, other, and select Gradle tasks. And now once you have this window open, expand the scaffold that you imported, expand Battlecode, and run a few tasks. Looks like update and build. So double click here. Just wait for that to complete. I think it worked. And then double click build. This one takes a bit longer. Cool, that worked. Next up is after you've done that, you should see a new folder called client. Let's see if it appeared. What did I do? Or maybe we have to unpack client. No. Wait. Wait. Let me check my other one. I think I did. I'm gonna try building again. Let's see if that fixes the problem. It looks like it built. I don't see anything called client. Sorry about this. Yeah, maybe I'll start Eclipse. That's probably gonna solve it. Once you open Eclipse a few times in your current session, it's a lot faster. Okay, so we're back. Once it starts, open this thing again. I think it's still loading. There we go. Client still does not appear to exist. Not sure what's going on. Maybe we can try these things again. Okay. Let's do Battlecode. Which one's first? Update. Build. Let's check. This is in the file system. Oh, it is. Okay, so Eclipse is just not recognizing it as a thing. How do we refresh Package Explorer? Wait, what? Oh, cool. Okay. So yeah, right click on the project and click refresh. And there we go. Client finally exists. There's an exe file here. Double click that. And the client should be running. Cool, here we go. So this is the Battlecode 2025 client. Some of you may have seen this before. You can see there's a game tab when you run a game. Some tabs will pop up here. Queue tab where you can upload a PC25 replay file, which is created whenever you run a match and watch the game happen. You can also run games right from here. So you select your language, select Java version, select your two teams, and select any maps that you want to play on. Click run, and it should calculate what happens in these games. Okay, first game's completed, and let's do one more. You can see as it's calculating, the stats are changing. So this is the number of specific types of towers or units right here on the left. Here's paint coverage and chips, and here's graphs. Pretty nice. And now the queue contains one game. And if you want to upload more games, you just go to here and select your game file. This one's almost done. There we go. Cool. And then you can replay the games. Yeah, if you click on either of these links in queue, you can replay. It starts off slow. You can accelerate that. And you can use these other controls, step backwards, enable playback return, like that. You can hide this thing like that, and press C. Also does the same thing. Jump to start, jump to end, just controls like that. And there's a few other things. There's a map editor. This is the help, so you can see what all the tabs do. And there's just some settings right here. Okay, so now we explored the Battlecode client. Let's not do that. Okay, cool. Okay, so now we're going to move to the portion of today's lecture, which is getting started with Java. This doesn't work, so.
Okay, great. Okay, so now we're going to move on to getting started with Java. Okay. So great. So to start off with Java, we're going to take a look at some variables. So variables, when you define them, you have to specify the type and name, and also how you're going to initialize it. So for example, we start off with int x, so we have an integer, that's the type of the variable, and the name is x. But if you see, I haven't set it equal to any value yet. I actually do that later on the 5th line, setting x equal to 25. So that's one example, but we also have double, y equals 0.21, string s equals hello, boolean is bot equals true. And something important to note is that there is a semicolon at the end of every statement. That's a part of Java syntax. Next, we have constants. So constants are declared with the word final in front, and you have to specify the value. So final string name is bot1, file int players is 50, double year 2025, for example, and then we see that we have the semicolons at the end of the statement. Next, looking at if statements. So here is an example of an if statement. Note that I have indented for better readability, but one difference between Java and Python is that Java does not really care about indents and Python does. So just looking at this example here, so we have if a num is less than 100, then this it prints out that the number is less than 100, else the number is greater than 100. If you just wanted the if, then you can just get rid of the else if you don't want it to do anything if the number is not less than 100. So the next is for loop. So we can see inside this class over here, I have defined an int x. Note that I haven't initialized it yet. And then I have a for loop for x equals 0. It goes all the way up to x is less than 10 and increments by 1. Then the system prints that this is x and then what x is. Also note that with this print statement, how I have the plus here. So combining these two, this is x colon space with what x actually is to get this is x0, this is x1, etc. So yeah, this is a method. We have public, so that's the access specifier, the keyword static, void return type. So void means that it doesn't return. Then we have main, which is the method name, and then string args, which is an array of string types. So this is a good diagram of the different data types in Java. So primitive versus non-primitive. Then within primitive having Boolean, numeric, and then within numeric character integral, within integral, integer, and floating point. And then here we see the different stuff that we went over with Boolean, int, string, float, double, character, etc. Char. So here's an example of a Java class. So first line, we have a package. So the package must match the path to the Java file where it's stored. Then we have the class, so public class, example class, and the class name must also match the file name. Then we have fields, so here on line 4, we have private, so going back to the public, private, the access. So this is set to private. This line defines an integer field named field1. And also we see that it isn't initialized yet. Then we have a constructor, so describes how to make a new example class object. And so, yeah, that's it for Java. And now moving on to Python. So in Python, the object on the left of an equal sign is the variable name, and the object on the right of the equal sign is the value. So if we were to define a variable a to be equal to 5, and then we wanted to print a, we would say a equals 5. And then when we do print a, we see that Python printed out 5. However, if we wanted to reverse the equation and then print a, so if we had a equals 5, sorry, if we have 5 equals a, and then we print a, we see that there is a error because a is an undefined value. So in general, variables are one word. And if you want a variable called my name, you could write it as my a capital N name or my underscore name. And then in strings, so in Python, phrases such as hello world are called strings, and strings are denoted by having quotation marks before and after the phrase. So if we wanted to print the phrase hello world, we would type print, and then the phrase that we're printing goes inside. This is a different syntax than Java, where we have the system out configuration. But here, if we're doing Python print world, then we see that Python would print out hello world. So now looking at numeric syntax. So in Python, there are two main types of numeric that I will go over, which are int and float. So int or integer, those are positive or negative whole numbers. They don't have decimals. And then floats are numbers that can be written in either positive or negative, and they can contain one or more decimals. So let's define a variable a to be equal to 1 and a variable b equal to 1.0. So to us, 1 and 1.0 are the same thing, but Python treats it differently. And so just to see that we can print the type of a and b by using the type function. So here we have a equals 1, b equals 1.0, printing the type. So print type A, print type B. Then we see that it prints that A is class int and B is class float. So this goes back to B having the decimal and A does not. So now we can move on to intro to Git.
So back. We're going to talk about Git now. So what is Git? Well, it's a version control system. So if you make changes to your Battlecode bot and you want to save both the original version and the new version, then Git can help with that. Also, if you want to branch into two different versions and like make two different changes at the same time, or have two different people working on the thing at the same time, and later merge them together, Git's really useful for that. So let's see what kind of things Git or other version control things can do. So they're good for collaboration. It'd be really annoying to have to like share your code files with everyone. Everyone has like a slightly different version because everyone's working at the same time. And then we have to like combine them into a single file. That takes a long time. And Git does this automatically if you do it right. And also, it's good for branching, like I mentioned before. Like if two people are working on things, it's completely separate. And also, like if you break something on one branch, it's not going to automatically break something on the main branch. So you can always like undo it, and it doesn't automatically cause any problems. And then also, another good thing about Git is previous versions completely saved, and you can easily revert to them. So what's the difference between Git and GitHub? Git is the offline system that you use locally. GitHub is a website. You can make a GitHub account and upload your Git repositories to GitHub, and it makes it a lot easier to collaborate and to publish your code. Especially if you're on like a multi-person team, it would be useful to use GitHub. And I showed you how to use the scaffold in GitHub in the first part of this lecture. So some things you might want to do when you're using these. First, you have to download Git, of course. Here's a link right here. And you should also make a GitHub account if you want to collaborate or if you want to publish your code. That's github.com. And in Git, if you want to set your username and email, then you just use these two commands at the bottom. Git config global user.name and user.email. You type these into a terminal, which is command prompt on Windows or Bash on Linux. Probably used that before, but if you haven't, just like go into the start menu and search for command prompt or Bash. So once you've done that, then you're ready to use Git. Here's how it works. So you have a local copy of your code. That's the working directory. Now let's save it on your computer. And if you make changes to that, then what we can do is stage the changes. And that puts them in a separate storage place called the staging area. They're not like committed. They're not in the like the public version of the code in GitHub, and they're also not on the they're not like saved as part of the main piece of code in your laptop either. And to save them like that, you commit them. So that moves them from the staging area to the local repository, which locally stores all your code, and then push is a command which sends them to the remote repository, which is GitHub, usually. You can also do things in the reverse direction. If you want to pull code from GitHub, then use fetch to first check what code exists on the remote repository and see what changes other people have made. And then you can use pull or rebase to put that into your workspace. And there's also other commands, which we'll see later, I think, like checkout, switch between branches, and you can create branches and you can compare files also. Let's look at that now. So git clone is the first command that you'll probably use. That downloads your repository from a remote repository. This is what you need to use if you don't want to go the VS Code route in cloning the Battlecode 2025 scaffold. Use git clone. There's also git add, which adds certain changes from working directory to the staging area. Git commit moves them from staging to the local repository. Git push, it pushes to the remote repository, and just public that releases them publicly. Pull changes back to your workspace, and status just shows you the status of Git, and it shows you information about working and staging. So now we're going to talk about branching. It's a very important feature of Git. So a branch is basically a separate code storage area where if you make a change in the branch, it won't make a change in the original code. And this is useful when you don't want to mess things up, but you're making like a big change, or when you want to collaborate with people and work on the same code at the same time. So to create a branch, just use the git branch command, and then type in the name of your branch. And to switch to a branch, use git checkout, and then the name of the branch you want to switch to. Git merging. So once you have your new changes in the new branch, and you want to put them back into the original branch, then use git merge. Basically, this will try to integrate all the changes that you made in your branch with whatever changes have been made to the code in the main branch. And when you type git merge, then it's merging the branch name you type into your current branch. So you want to switch to the main branch first if you want to merge into the main branch. One more thing on GitHub, you might need to create pull requests instead of just directly doing git merge. This is a useful feature if you're working on a large team. It allows people to like verify that your code is good before integrating it into the main branch. So when you do git merge, you might find the merge conflict. And this is when like the same piece of code has been changed or the same file has been changed in a way which Git can automatically fix. And to fix a merge conflict, you open up the file which has the conflict, and you'll notice that Git added these the less than, equal to, and greater than signs, and also the names of the two branches. So the thing in between the less than and equal signs is the code in the branch that says next to the less than signs, in this case head, and the thing between equals and greater than is the code in the other branch. So you just basically delete the 3 lines of less than, equal to, and greater than signs, and then like either combine these 2 pieces of code or only use one, or you can do some combination of that. You can put whatever code you want in place of this. So basically, you can just like, you can integrate some elements of one, some elements of another if different things are correct, or you can basically do whatever you want. And once you've done that, you do git add, and then the name of this file, and then git commit -n, followed by your commit message. Commit messages are just a good way to keep track of what each commit is for. So I think this is, yeah, I think this is just an example. So yeah, so I'm not going to work through this right now, but basically what's going on here is you're cloning the scaffold. This is the command that you'll want to use in the when you're cloning the scaffold, like I was describing before, if you don't have VS Code and you don't want to download it. So once you do that, it's in a folder called Battlecode 25. Go into the, we're called Battlecode 25 scaffold, I think. Go into the Battlecode 25 scaffold folder. You change some things, you can do whatever you want, make new files, and then use git add to add the files, and git add dot is going to add all the changes. Then if you're sure that your changes are good, then you want to do git commit -m, and then the commit message in quotes. Not sure why these quotes are fancy, but yeah, after that, to push your thing to the remote repository, use git push. And then once someone else makes changes and you want to pull them to your local repository, use git pull and continue working. So here are other things you can do. You can use git revert to undo a commit. You can use git stash and git stash pop. And what these do is you can basically save your you can save all the changes you made which are not committed and put them in a safe place, and then you can do whatever you want and then reapply the changes. And this is useful if you want to like pull in code from a remote repository that's been changed, and you want to like integrate your new changes with that. Then there are also Git GUIs, graphical user interfaces. These are useful. There's the command line / terminal, which is not a GUI. That's just the default Git system. And there's also the GUI systems like Git Kraken, which is pretty cool. And GitHub Student Developer Pack contains Pro version. And then here's just a link to a cheat sheet. Slides will be posted, so you can click on this link. And there's a lot of useful information about Git commands here. Thank you. That's the end of the lecture part of this